Hello, welcome back to Mr. Weed and Maths. We're on a brand new topic today called product rule for counting. So I've got an example over here. We've got in a restaurant, there are 4 starters, 5 mains and 3 desserts. What we're going to do is work out the total possibilities this could be. Now, let's say, for example, one of the starters was soup, and then one of the mains was fish and chips, and then the dessert was ice cream, for example, okay? Now that is just one combination you could have, but there are quite a few different ways of writing this. For example, let's say we kept the starter the same and we kept the main course the same, but we changed the dessert. And maybe one of the other 3 desserts is, I don't know, let's go brownie, for example. We've already got 2 options here, and all we have done is change the dessert. And then we would have to keep going and keep going and keep going and writing every single possible combination there is. Now, luckily for us, there's a much quicker way than doing this. We don't want to list the outcomes every single time. We just want the total number of combinations of meals at this restaurant. So, rather than writing it out each time, we take the starters and the main meals and the desserts and we multiply them all together. And that will find us all of the possible combinations that there are. So we're going to do 4 times the 5, which is 20, times by the 3, which is 60. So we have 60 combinations of 4 starters, 5 main meals and 3 desserts. That's it. Okay, we do a bit of multiplying of all the options. Next one. So we're going to go for a complete new scenario now, and we're going to go for a code. We're going to go for a 4-digit code, like the old iPhones used to be, a 4-digit code before all the updates. So we've got 4 numbers, 4 digits that it could be. In my very poorly drawn attempted squares there, but they're all different sizes and stuff. So here, this could be any digit. It could be 0, it could be 1, 2, 3, 4, 5, 6, 7, 8, or 9, okay? So what you've got to think is, how many options could this first box be? Well, we just listed them. There were 10 different digits. Remember, we're starting with 0, so we include it. So that is 10 options here. So it could be a 0, or a 1, or a 2, all the way up. Now this one could also be 10 different options. So you could have 0, 1, or you could have 0, 2, or 0, 3, or 0, 4, or 0, 5. So that means I'm going to have to multiply by the 10 options here. So just in 2 digits here, you could have 100 different numbers, because you could have 0, 0, for example. Okay? And then let's say we get over to here, and we're thinking, how many options could go in this digit here? Well, we've got 10 again, so we would times by 10. And then the last one, we would times by 10. So overall, for a 4-digit code, there would be 10 times 10 times 10 times 10. So we would have, what's that going to be? 10,000, okay, as our answer. There are 10,000 combinations in a 4-digit code. You could make it more complicated, or just a slightly harder bit of maths, by saying, oh, actually, rather than digits, I wanted a letter on the end of my code. Well, how many letters are there in the alphabet to choose from? There are 26. And we're not including special keys on our keyboard or anything. But that would mean I have even more options to choose from. And that would mean there were 26,000 combinations, okay, to choose from on this particular code. Now, we're going to look at one last example that's a slight bit different from product rule for counting. So far, it's all been about multiplying by the amount of options there are, and then you get the total amount of combinations. Now, this last one, we have 52 cards in a pack, or a deck. A deck. Now, let's say, for example, you are trying to figure out how many pairs of cards you could get. So how many pairs of cards could you get? Now I'm hoping you're instinctively thinking, well, there are 52 cards. So on my first pick of a card, there are 52 options for us. Well, and then on my second pick of a card, I've taken one of them out. So I would times it by 51. And you might be thinking, well, I'm done, surely. Actually, on this particular example, because it mentions the word pairs, you've got to think a bit more logically. Let's say, for example, you had a 2 of hearts, okay? 2H, we'll call it, on your first pick. So over here, you picked a 2 of hearts, all right? But then, on your second pick, let's say you got a 10 of diamonds. Now, what you have calculated is definitely in here, but you have also calculated, with this calculation, picking the 10 of diamonds and the 2 of hearts in another order, all right? That's what the 52 is doing. And times by the 51, it's accounting for every single possibility. You've got 2 of hearts being picked first, and then the 10 of diamonds, and it's also accounting for the 10 of diamonds and the 2 of hearts. Well, that's actually the same pair. So that's too much of an answer. So in this particular case, when it's talking about pairings, we only want one of these answers. So let's say the first one. So to account for this, you have got to do a divide by 2. Okay? And then you would type this into your calculator. This would probably be a calculator question, and you would finish that off. So just be really careful when it mentions anything about pairs or repeated answers, that you've got to divide through by 2 to make sure you cancel those repeats. Okay, that's it for this particular topic. On to the next one. All the best. Have a great evening. Bye.